Today is day 11 for geometry. Please take out your homework, page 27. Class packets are open to page 28. You'll need your pens or pencils, highlighters, calculator, your geometry, ruler or protractor, your quadrilateral organizer or check-off page, and a piece of notebook paper. Please get those things out so we're ready to begin the lesson. At this point in time, we want to make sure that you're turning in your homework from page 27, as well as any late homework from the last 5 days. Please pass up those homework assignments for the substitute to pick up from each group along the way. Please pause the lesson until this is completed. Today we'll be looking at the properties of trapezoids as well as isosceles trapezoids. So on your quadrilateral organizer, your checkoff list, we'd like to make sure that we're labeling our shapes trapezoids for S, T, and U, and our isosceles trapezoids for our shapes V, W, and X. On the left side of your organizer, for right now, the trapezoids do not have anything checked off. The isosceles trapezoids, on the other hand, has pairs of diagonals that are congruent, so we want to make sure that our boxes V, W, and X have the diagonals are congruent marked. Continuing to the right side of our organizer, our trapezoids have one pair of opposite sides that are parallel to each other. We want to make sure that our figures S, T, and U for our trapezoids have only one pair of opposite sides that are parallel to each other checked off. Our isosceles trapezoids are still trapezoids that have one pair of opposite sides parallel. However, they also have one pair of opposite sides congruent, therefore making it isosceles. We'll have base angles that are congruent to each other. And we'll also have two pairs of consecutive angles that are supplementary. Please make sure that we have the right side labeled for our trapezoids and isosceles trapezoids. One pair of opposite sides are parallel for all trapezoids. Isosceles trapezoids, only one pair of opposite sides congruent. Base angles are congruent, and two pairs of consecutive angles that are supplementary. Proceeding on to our class packet, page 28, we want to mark as well our rules for our trapezoids. So we want to make sure our properties of trapezoids are circled, starred, and highlighted. And we want to make one change to our definition for our properties of trapezoids. A trapezoid is a quadrilateral with at least one pair of parallel sides. So you want to make sure you're changing the exactly in that first sentence to at least. The parallel sides are referred to as the base or bases. And then we have what's called to our base angles. We have two pairs of base angles. Typically they're called lower base angles and upper base angles. In our diagram for our trapezoid ABCD, angles A and B would represent the upper base angles, and our angles D and C would be our lower base angles. What makes the trapezoid isosceles, it still has at least one pair of parallel sides, but then it also has a pair of opposite sides that would be congruent to each other. We're going to look at that fact in our example 1 proof. Please take a few moments and allow the students to work on example 1. Here we are given that MNOP is an isosceles trapezoid And we like to prove that our segment MO is congruent to NP. Here on our proof, we want to prove that MO is congruent to segment NP. These two segments represent diagonals in our trapezoids. Since we want to prove those segments congruent, that would have to be at the end of our proof. To start our proof, we'll look at our givens. We know that MNOP is isosceles trapezoid. If it's isosceles, that means it would have one pair of opposite sides congruent. So segment MP would be congruent to segment NO. Our segment PO is congruent to itself by the reflexive property. If it's isosceles, not only would it have two sides that are congruent, but it would also have two base angles that would be congruent, the angles opposite those sides. Angle MPO is congruent to angle NOP. This leaves us with two congruent triangles. Triangle MPO would be congruent to triangle NOP by side angle side. Since the triangles are congruent, their corresponding parts are congruent. Therefore, segment MO is congruent to segment NP by CPCTC. Corresponding parts for congruent triangles are congruent. Let's continue on to the next page and look at our example 2. Example 2, you'll need your geometers, rulers, and/or protractors. Because we're going to be doing measurements, let's label the vertices for each of our diagrams. So please take a moment and label our vertices A through H. This sculpture that's pictured are walls connected at right angles. In perspective, the rectangular panels appear to be trapezoids. Please use your ruler, protractor, and/or geometer to determine if the images of the front panels are isosceles trapezoids. Once you have your measurements, please explain your answers. Please pause and allow the students to collect the measurements and determine whether or not the panels are isosceles trapezoids. While reviewing the measurements, we see that our figure ABCD would be considered an isosceles trapezoid. We have two segments that are congruent to each other, and we also have a set of parallel lines. We can tell that they're parallel because we have consecutive angles that are supplementary. If we look at our measurement for angle A and we add it to angle D, those are supplementary angles. If we look at our measurement for angle B and C, these are also supplementary angles, therefore making our segment AB parallel to CD. So that's how we're getting a trapezoid, one set of parallel sides. It's isosceles because our measurements for our segments BC is congruent to AD. However, when we look at our second figure and we look at our angle measurements, we have two sets of supplementary angles, E and F, with G and H. So it is a trapezoid because it has at least one pair of opposite sides parallel to each other. However, it is not isosceles because it does not have a pair of opposite sides that are congruent. So our figure ABCD is considered an isosceles trapezoid, while EFGH is not. Let's take a look at our example 3. We're taking it to the coordinate plane. Here we have our quadrilateral JKLM with our vertices as they are listed in our directions. Please take a moment and have the students verify that JKLM is a trapezoid by performing the calculations on their papers. Please pause and allow this to happen. One way we can verify that JKLM is a trapezoid is to see if we can determine that it has at least one pair of opposite sides parallel to each other. I tried our segments JK and ML to see if they had the same slopes to determine whether or not they are parallel to each other. By looking at my data, I see that the slopes are the same, therefore the lines or the segments should be parallel. So I know JKLM is a trapezoid because it has at least one pair of opposite sides parallel to each other. Now what I like to do is to see if this is an isosceles trapezoid. So based on my data, please give students a moment to determine whether or not JKLM is an isosceles trapezoid. Please pause and allow this to happen. The way I can determine whether or not it's isosceles is finding the lengths of a pair of opposite sides that are congruent. So I'm going to determine the distance from JM to KL by using my distance formula. When I calculate the distance for each of these, I get MJ to be 25 and KL to be 25 as well. This proves that we have a pair of opposite sides congruent. Since it's a trapezoid with a pair of opposite sides congruent, it would be an isosceles trapezoid. Let's turn to the next page and look at the second part of our activity. Here, what we need to do is work on finding some measurements. So, as students came in their folders, there was a number written on a piece of paper. That number corresponds to the figure that they are responsible for conducting the measurements of. The measurements that we need to collect are the following. The first part that we need to do is make sure that we are drawing in the median. So we are starting with our part B. So you'll take your straight edge and connect the midpoints of the legs for our figures and draw on a segment. The second step is to measure the bases as well as the median and legs. So we are measuring all segments of our figure. The third part is that we need to measure the base angles for our figure. And our last step is to note any conjectures, any patterns, any relationships that you see based on your measurements. Please pause and allow students to collect the measurements for each of their figures. Let's take a look at the results of our measurements and see if we can come up with any conjectures about these trapezoids. For our figure 1, our bases are segment AB and DC. Our legs are segments AD and BC. As you can see with our measurements, we have lengths for the bases being 4.2, 2.2, and our median is 3.2. Our angles for A is 75, B is 60, C is 120, D is 105. I'm noticing by looking at these measurements is that 60 plus 120 is 180 degrees. 75 plus 105 is 180 degrees. So I would have parallel lines. AB would be parallel to DC. Since I have constructed the segment with my medians, that would also be parallel to the two lines that are given. So my segment M1, M2 is parallel to AB as well as DC. Our figure 2, our bases are segment HG and JK. Our legs are segments HJ and GK. If I look at the measurements for the bases, I've got 2.4 and 3. My median was 2.7. My angle measurements for G is 103 degrees, angle K is 77 degrees, angle H and angle J are both 90 degrees. Again, I have some supplementary angles. Angle H is supplementary with J. Angle G is supplementary with K. I have parallel lines then with JK and GH. And because I constructed the median from the midpoints, I also have that parallel to my two bases. Looking at our measurements for 3, we've got our bases here for segment LM and PN. Our legs are segments LP and MN. The measurements of the bases are 4.9 and 6.1. The length of our median is 5.5. I'm looking at my angle measurements. Angle L is 120. Angle P is 60. Here I have a pair of supplementary angles. Angle N is 97. Angle M is 83. Again, I have another pair of supplementary angles. So I know that PN must be parallel to LM. Again, when I constructed the median, it's with my parallel line, so all 3 of these segments would be parallel to each other. Looking at my step 4 here, my bases are segment OR and TS. The legs are OT and RS. The measurements of my bases are 4.3 and 3.2 centimeters. My median was 3.8 centimeters. Angle O is 110 degrees, angle T is 70 degrees. Again, I have a pair of supplementary angles. Angle R is 56 degrees, angle S is 124 degrees. These are supplementary as well. That means that my segment OR must be parallel to TS. Again, because I constructed the medians, that would be parallel to my 2 lines given. So OR, M1 to M2, and TS would all be parallel to each other. So I know we have 3 parallel segments, but also we've been looking at these measurements, 4.3, 3.8, 3.2. We know that the median should be in between the values of our 2 bases, and looking back at our others, we saw the same pattern. That's our middle value for the median in each of our diagrams. Well, we want to ask ourselves, is there a way that we could determine the length of the median from the lengths of our bases? And we've done this with our triangles before. We know that a mid-segment sounds like the middle. A mid-segment was always half the length of the segment it was drawn parallel to. Well, here we have a median that's drawn parallel to 2 segments. So we're going to kind of build off of that idea of a mid-segment and relate it to our median. Hopefully, as you guys were looking through the numbers, you noticed a pattern between the lengths of the bases and that median. A median, we know, has to be parallel to the bases. Since it's parallel, it's creating this pattern where the length of the median comes from half the sum of the bases. It's the middle. It's the average of the bases. Sometimes you'll see the formula written as a capital M that represents your median equals 1/2 the sum of your bases. To show the sum of the bases, we use B1 plus B2. This is similar to your midsegment, where the midsegment was equal to half of the base. Because it was coming from a triangle, it only had one base. Here we have 2 bases, so we need to use the sum of them to create our median length. So tonight for your homework, you're going to be still applying all the properties from our previous shapes, as well as practicing our properties for our trapezoids. So as you look at your homework for tonight, you'll be applying those as we are going forward. Remember, your homework should be done on a separate sheet of paper. All calculations should be shown. And if you are writing any explanations out, use sentences to complete that pattern. You do have some coordinates given to you on numbers 4 and 5, so you may want to graph it to get a visual so you can see the picture that will help you with your proving whether or not it's the figure listed. Remember, when you're doing coordinate proofs, your methods that you could use would be distances, slopes, midpoints, or a combination of those items to help you get to your conclusion. With the time that you have remaining, please work on your homework on page 31. There will be an answer key posted on the bulletin board, so you may check your progress as you are working on your assignments. You are working individually, not with partners, on this assignment. Please begin now.